November 2022 session, which we are looking at Combined Science Paper 2. We are given structure in question 1. Figure 1.1 shows the diagram of a specialized cell. There's chloroplast. There's feature X. The first question says, identify the cell in figure 1.1. How do you identify the cell? You look at its features. You know that a specialized cell is a cell which contains special characteristics that set it apart for a particular function. One thing you should always look out for in biology is how structure is related to function. So here you see that the cell has got a lot of chloroplasts. You can see those chloroplasts. There are a lot of them. You can also remember that the chloroplasts have got a function for absorbing light. So that cell is specialized for absorbing light due to the large number of chloroplasts there. Then it is long. You can see that the cell is long, so that makes it able to be pegged in a certain columnar arrangement in which the cell has got maximum surface area pushed out so that it can absorb as much sunlight as it possibly can. So you can obviously see that this cell is a palisade cell, which is found in the leaf. So that one is a palisade cell. Its function is to absorb light and make food by photosynthesis. All right. The part X there is largely centrally positioned, so it is a vacuole. Its function is to absorb water and is a storage for nutrients, for minerals, etc., etc. So because of that, it helps to maintain the Tegger pressure or the firmness of the cell. Question 2. Question 2 says, describe what happens to the glucose and oxygen made in a leaf. So the glucose is a source of energy. It is broken down during respiration to produce energy and release carbon dioxide. The glucose is also used as a building block for other organic molecules. For example, you can use it to make starch, which is the major component of storage in plants. You find that they have starch granules. It can be used to make cellulose, which makes the cell walls. And it can also be used to make sucrose, which is the sugar that many fruits contain. Or you can also use to form maltose, which can then be used to form starch or other things. And it can also be used to make amino acids, which are later used to form proteins due to the buildup of amino acids amino acid chains. All right. They can also be used to make cell membranes when they form a carbohydrate chain, etc. So that is the function of glucose. Oxygen, on the other hand, is a byproduct which is released either into the atmosphere, or it can be used for cellular respiration by the plant, or it can be given out and taken up by other plants to use again also for respiration. Part C, give one function of guard cells. Guard cells regulate the opening and closing of stomata. So it means that they are responsible for gaseous exchange and water loss. Explain how the guard cells are adapted for their function. So the adaptation is that when guard cells absorb water, they become turgid. So here, when guard cells absorb water, let me just add that here, they absorb water here. When guard cells absorb water, they become turgid and form a crescent shape. So they form a shape somewhat like this when they absorb water, and then they form this open stomata structure. And when they lose water, they become flaccid. So when they become flaccid, they somewhat close that gap which was in between them and close the stomata. So they absorb water to open the stomata, and they lose water to close the stomata, and thereby allowing gaseous exchange. Name any two female sex hormones. We have our two common hormones, progesterone and estrogen. These ones are the common hormones. Of course, you can talk about luteinizing hormone, follicle stimulating hormone, but it would be safe to stick with these ones. Describe the roles of the hormones named in A in the menstrual cycle. Estrogen, its main function is to cause the uterus lining to rebuild after menstruation. Remember, after menstruation is that process where the endometrium or that inner lining of the uterus degenerates and is expelled with blood, with the dead egg, as well as some blood vessels which they have formed. Now, after it has gone out, the estrogen, which is going to be released by the ovaries, is going to cause the lining of the uterus to rebuild again after menstruation. Then it's also going to influence the release of follicle stimulating hormone, which is going to cause one follicle to mature into an ovum in one of the ovaries. And it is also going to cause luteinizing hormone to be released, which is the one which is going to cause the release of one egg during ovulation. On the other hand, progesterone maintains the thickened lining in preparation to receive a fertilized ovum in the uterus. So it also prevents or inhibits the production of follicle stimulating hormone and luteinizing hormone from the pituitary gland. Moving on, define the term ovulation. So ovulation is the process where one egg is released, a mature egg is released from the ovary, influenced by a peak in the levels of luteinizing hormone. State the range of days of the menstrual cycle when sexual intercourse is most likely to result in pregnancy. Obviously, this would have to be the days just before and just after fertilization. So most likely it will be around day 12 to 14. Sometimes you can see sources say day 12 to 16 of a 28-day cycle. 2 days before, 2 days after, sometimes maybe day 11 until day 17. But as long as you mention that it's a few days before and a few days after, including the day. All right? State any two processes, question 3, which can be used to support the kinetic theory. So, to support the kinetic theory, we have to first appreciate that there are particles which are always moving in random motion. This is the Brownian motion theory. And then these particles can have a net movement from where they are mostly concentrated to where they are least concentrated. This is the process of diffusion. So diffusion and Brownian motion are the two processes which support the kinetic theory of matter. When a gas is compressed, state the property which increases. So when you compress a gas, it means that you're going to close in on the spaces, the free spaces in which are present between each of the particles in the gas. So that means you're going to be reducing the volume. But by reducing the volume, you're going to increase the pressure because the particles are going to be closer together in a small place or in a small volume. So you're going to increase the pressure. When you increase the pressure, the temperature is also going to increase because the molecules will have more chances of colliding against each other. So the pressure and the temperature increase and the volume decreases. This is, of course, explained by the ideal gas law, which says PV is equals to nRT, and P is standing for the pressure of the gas, V is the volume of the container in which the gas is, or wherever the gas is, where N again is the amount of gas particles there. The R is standing for the gas constant, and T is the temperature, which is the temperature of the particles of the gas. Okay. The next question says, explain why it is easier to compress a gas than a solid. So here, you know that a gas has a lot of empty spaces between its particles, which make them able to move more freely than the particles of a solid. These spaces, therefore, can be reduced by applying pressure. And this is, we are applying pressure, we're going to close in on the spaces. On the other hand, a solid has got very little empty spaces between its particles, which are tightly packed. And therefore, these particles are held together by strong forces. Hence, it is very, very difficult to compress a solid. And therefore, a solid will resist compression and maintain its shape and volume largely. A science teacher orders iron, zinc, copper, and magnesium for use during laboratory practical lessons. From the ordered material, state the one which reacts very slowly with air to form a greenish compound. So this one is obviously copper. It reacts in two reactions. Firstly, it's going to react with oxygen to form copper oxide, which appears greenish because it is in the +2 state. This copper is in the +2 state. So it appears somewhat greenish blue. Okay, it appears somewhat greenish blue. And on the other hand, it can also react with carbon dioxide to form copper carbonate. Again, you can see that copper carbonate in this state now, it is again somewhat greenish. It takes up a somewhat greenish color. This accounts for the reason why the Statue of Liberty in America appears somewhat bluish green, because it was made with copper. But over time, that copper is reacted with oxygen and atmospheric carbon dioxide and has formed that copper oxide layer and that copper carbonate layer. Now, those copper carbonate layers and the copper oxide layers forms that kind of rusty look there, which protects or prevents further rusting of the copper and thereby forming a protective layer on the outside, and therefore it stays like that. From the ordered material, state the one whose powder bends to form a yellow oxide when hot. This is obviously zinc, because when you heat zinc in air, it undergoes a chemical reaction to form zinc oxide, and it bends and forms a white or yellowish powder when it is still hot. The chemical reaction is zinc plus oxygen to form zinc oxide. So remember to balance. When you use chemical equations, you need to balance them. So you have 2 zinc on the left, 2 zinc on the right, 2 oxygen on the left, 2 oxygen on the right. Moving on, which metal burns easily to form a white solid? This is, of course, magnesium. You must have done this practical by now. This one burns with oxygen to form magnesium oxide, which is somewhat a rust. So this magnesium powder or ribbon is heated strongly in air. It forms very brilliant light or yellow fire and quickly burns out to form this white powder of magnesium oxide. Arrange the 4 metals in their order of decreasing reactivity. So if they're decreasing reactivity, so it means that the one which reacts the most is on top. Obviously, that would have to be, number 1 would have to be here, magnesium. And number 2, you'd have your zinc second. Then you'd have your iron. And then you'd have copper. Okay? Because you can use the Postolica Mazilk to check your reactivity. You should know this acronym Postolica Mazilk, where P is standing for the potassium. This is potassium. Then this is sodium. Then this is lithium, calcium, magnesium, zinc, iron, this is Fe. Then you have lead, Pb, and then you have your copper, Cu. Okay, this you can use this Postolica Mazilk to remember your order of reactivity. So you can see here potassium, sodium, lithium, calcium, magnesium, aluminium, carbon is not a metal though. Zinc, iron, hydrogen is not a metal again. Copper, silver, and gold. So you can see here that our order was correct. We had magnesium, then we had zinc, then we had iron, and then copper. So in order of decreasing reactivity, you have your magnesium first coming 1, you have your zinc second, you have your iron coming third, and you have your copper coming last. Okay. Some people use this mnemonic, please send lions, cats, monkeys, and cute zebras into what countries signed codon. This one is more for those ones who like literature and English a lot, but it can also help you to remember the Posolika-Mazilk order of reactivity. So using this order, we can see that we have magnesium first, because magnesium even reacts with steam to produce magnesium oxide and release hydrogen gas. We have next zinc, and then after zinc we have iron, which is more reactive than copper. Explain why an iron nail placed in copper sulfate solution becomes coated with copper. So this is due to what we call displacement. So a displacement reaction takes place here. Because iron is more reactive than copper, it is going to displace copper from its salts and take its place. So this is going to happen because when metals which are higher up in the reactivity series get into a solution or a compound or a salt in a solution or an aqueous solution which is the salt of a metal which is below it in the reactivity series, it is going to displace it or remove it from its salts or compounds. So the iron will lose its electrons and form iron sulfate in the solution, whilst the copper ions are going to gain these electrons and form copper atoms on the surface of the iron nail. So the equation for the reaction is as follows: iron plus copper sulfate to form iron sulfate plus copper. State one difference between a petrol engine and a diesel engine. The petrol engine uses a spark plug to ignite the fuel mixture or the fuel air mixture, but a diesel engine does not use the spark plug. It uses compressed air to inject and ignite the fuel. So whereas petrol engines use spark plugs, diesel engines use fuel injectors. All right. Of course, the newer petrol engines are now using fuel injection technology, but this is one of the major differences. Other differences include petrol engine has got a lower compression ratio, 25%, compared to a diesel which has got 40%. Therefore, the diesel engine compresses more the fuel air mixture before ignition. A petrol engine produces less power and torque than a diesel engine, although it has a higher speed and a higher acceleration. A petrol engine uses more volatile fuels such as petrol or gasoline, whilst a diesel engine uses less volatile fuels such as diesel or biodiesel. Okay, there's been this talk of biofuels where they are punched with like the Jatropha project, which is also a very important project, especially when we do not have reserves of diesel in the country or in the nation. All right. So these are alternative sources of fuel. Biodiesel, ethanol, you punch them, you produce a good fuel. A petrol engine also emits more carbon monoxide and hydrocarbons than a diesel engine. This is, of course, due to the fact that the petrol engine is going to have a 25% efficiency, whilst a diesel engine has got a 40% efficiency. It therefore means that more carbon monoxide, more unburned carbon is going to be emitted from the petrol engine compared to the diesel engine. But on the other hand, the diesel engine emits more nitrogen oxides and particulate matter than a petrol engine. State one difference, question 5, between a petrol engine and a diesel engine. We already stated it. The next question, describe what happens during the power stroke of a petrol engine. You should know that we have 4 strokes, so that you are well sure. We have the inlet stroke, we have the compression stroke, we have the power stroke, and then we have the exhaust stroke. So during the inlet stroke, the inlet valve is open, the outlet valve is closed, and the piston moves down, okay? In the compression, the piston moves up, both valves are closed. In the power stroke now, the piston moves down and the spark plug ignites, causes an explosion in the petrol air mixture, which is going to be used to generate the energy. And then in the exhaust one, we have the exhaust valve open, the inlet valve closed, and the piston moving up so that it can drive out the exhaust gases, mainly carbon dioxide. So to answer the question, in the power stroke, the petrol air mixture is ignited by the spark plug, and then the petrol air mixture explodes, giving off a lot of energy, and this causes a lot of pressure to build up in the cylinder, forcing the piston to move downwards. So we're going to write it now here. Petrol air mixture ignited by spark plug, it explodes, giving off a lot of energy, pressure builds up in the cylinder, and the piston is forced downwards. Name any two gases which are released in car exhaust fumes. These are a lot. You can choose from carbon monoxide, carbon dioxide, water vapor, soot, which is unburned carbon, nitrogen itself, because if some of it is not going to react, nitrogen oxides, you've got sulfur oxides, any gases you can name, you can choose from here. All right, state one effect of force. So a force is a twist, a turn, a stretch, a push or pull, which can have any of the following effects. It can cause a stationary object to start moving. For example, you flip a coin which was stationary. That's a force causing an object to start moving. You can have it causing a moving object to slow down, like when you apply pressure on the brakes, when you put some force over a small area, that's what we call pressure, then an object can be caused to slow down and eventually stop. You can have forces changing the direction of a moving object. For example, when you throw something at the wall and the wall resists whatever you've thrown there, that is what we call a force. It has caused the direction to change of a moving object. A force can also cause an object to change its shape, like for example, if you squish slime or use your hands to mold clay, that is how forces can change shape of an object. So choose any one from those ones that we wrote of the four, because you are only supposed to state one effect of a force. Name the instrument used for measuring force. The instrument is called a force meter. So it looks like somewhat like this, where the more that you pull here or put an object to drag it down, is going to calculate force in newtons. All right. Figure 6.1 shows an electric circuit in which a cell is used to light a bulb. Construct an energy chain for fig 6.1. In our diagram, you can see here we have a cell. The cell here is what is going to produce chemical energy. And then when it has got this chemical energy, it's going to convert it into electrical so that it can move through these wires. So these wires are going to conduct electrical energy. When it reaches this bulb, the electrical energy is going to cause the bulb to light and give off heat. So there's going to be some heat plus light energy. Okay, so the energy chain will be like this: chemical from the cell being converted to electrical so that it can move through the wires. Then that electrical is going to be converted by the bulb to light and heat. State any one effect of energy. To light bulbs, you can just write this one. This is a simple one. To light a bulb, to provide lighting, okay, in buildings. That's one simple effect of energy. Some of the other ones, like for example, sunlight makes plants grow to provide food for animals and oxygen for plants and animals. The energy in food helps us to move and keep us warm. The energy in fuel powers engines in industries, in transportation, etc., etc. Then the last question says, suggest one advantage of solar energy. Solar energy provides renewable energy which is limitless, okay? As long as the sun shines, we have energy, okay? So this is a limitless, renewable, limitless energy, limitless, yeah? And again, there are no greenhouse gases produced, so therefore there's no pollution. You can also generate energy in remote areas which are too far away for you to send pylons. So you can use the empty fields to generate energy, put solar fields there, solar panels, and then the energy can be generated and create a whole new grid. Again, the energy can be created there and sent to the main grid, which will mean that the energy bills are going to be reduced. So this marks the end of section A for November 22 science. Watch out for section B in the next video. Please follow our next video. Remember to like, to share, to subscribe, and don't miss a single video as you are preparing for your upcoming exams.